All right, quiz 4 solutions. Two different types of problems. Each type has two problems. This first one, we are using the evaluation theorem a couple of times to figure out the values of these two definite integrals. And then on this second one, it looks like a fundamental theorem of calculus problem, actually two of them, one of them that will involve the chain rule, one of them that won't involve the chain rule. For this first one, it's worth pointing out that I changed this to a positive one to make the problem work out. Maybe I can explain why I had to change that later on in 5.10 in your book. But when you see this, there won't be a plus here. Just if you're wondering why it looks weird, I want this to be the integral from 1 to 3, not from negative 1 to 3. Really what it has to do with is the fact that the function 1 over x is undefined at 0. So I don't want my integral to include a point where it's undefined. It kind of messes things up, informally speaking. At any rate, to use my evaluation theorem, I will first take the antiderivative of 1 over x, which is the natural log of the absolute value of x, and then I will evaluate that from 1 to 3. And that's easy enough. That's just the natural log of the absolute value of 3 minus the natural log of the absolute value of 1. And the absolute value of 3 is just 3. So this is the natural log of 3. And the absolute value of 1 is 1, but the natural log of 1 is 0. So I get the natural log of 3 minus 0. I get just the natural log of 3 as my answer. This second problem, much the same idea. We need to use the evaluation theorem, so we've got to figure out the antiderivative of cosine of x. I believe that's sine of x because the derivative of sine of x is cosine of x. And then we need to evaluate that from 0 up to pi over 2. So I don't know, maybe this is a little bit of unit circle knowledge. I need to know the sine of pi over 2, and I need to know the sine of 0. Realistically, if you got this far, I'm pretty happy. This isn't a trig class, but it would be good to know some of these values. The sine of pi over 2 is 1, and the sine of 0 is 0. So I get just 1 as my answer here. If you're having a hard time with those values off the unit circle, remember that the sine is always the y-coordinate on your unit circle. Wow, that's an ugly circle. And pi over 2 is up here, and 0 is up over here. So the height here is 1, and the height here is 0. Now my fundamental theorem of calculus questions. I can look at these and immediately know what the answer should be, and if you want to write that down, you can. But what I'm just going to do is say, all right, I could use the evaluation theorem here. 1 divided by the square root of t can be rewritten as t to the negative 1/2 power. So when I take the antiderivative of this, I first add 1 to that exponent. I get t to the 1/2 power. But then I'm not done. I have to multiply by the reciprocal of 1/2, which is this 2 here. And so my function g of x is 2t to the 1/2 power evaluated from x up to 3. And the way I determine this is I change all the t's into 3's first and then change all the t's into x's. So I get 2 times the square root of 3, or 3 to the 1/2 power if you prefer, minus 2 times x to the 1/2 power. So here's my function g of x. G prime of x is just the derivative of this guy. So the derivative of this is a constant, so it's 0. And the derivative of this, well, the 1/2 would come out in front. 2 times 1/2 is just 1. And then I'd have to subtract 1 from the exponent. What I get is negative x to the negative 1/2 power. But x to the negative 1/2 power is 1 over the square root of x. So what you see as my answer is almost what you see here, changing all my variables into x's. But because the x is in the wrong spot, I have to negate that thing. And then finally, this function, it's much the same idea. We start out by taking the antiderivative. The antiderivative of sine of t is negative cosine of t. And I want to evaluate that from 4 up to x squared. And so the way I do that is I first change all my t's into x squareds. So I get the negative cosine of x squared minus the negative cosine of 4. So my function g of x, thanks to the evaluation theorem, can be rewritten this way. And so that tells me that g prime of x is just the derivative of this thing. Well, this is all a constant, so that's just going to be 0. The derivative over here, the derivative of negative cosine of x squared, I'm going to use the chain rule. So first taking care of cosine, the derivative of cosine is negative sine. So I have negative negative sine, in other words, positive sine of x squared. But then I'm not done. I have to multiply that by the derivative of x squared, which is 2x. And then this is just a constant minus negative. That ends up with just being a 0. And I can clean this up a little bit and call it 2x sine of x squared. If you think that that's prettier, I kind of do, but you don't even have to. And so this is g prime of x. And you're like, oh, this is a lot like what I see here, except I'm changing all of the t's into x squareds, so sine of x squared, and then I'm multiplying by the derivative of this x squared, this 2x. And that's that quiz.